Assalamu alaikum students. We are doing the chapter forces and today I'll be taking the topic mass and weight. We will actually see the difference between mass and weight, and are they same, are they different? If they are different, what's the different? Let us see. What is mass? The amount of matter in an object is mass. So, as you know, what is matter? Matter means all things are made up of small particles, and these particles are nothing but they are called as matter. So, everything is made up of matter, of particles, small particles. And what are these particles? These particles are nothing but atoms. So, if you are talking about mass of an object or mass of a body, you need to know how much amount of matter or how much amount of particles, how many number of particles are present in that body. That gives you the mass of the body. But then if we are talking about weight, weight is the force of gravity that pulls on your mass. So now, what is this force of gravity? As you know, Earth has a force which is called as the gravitational force, and it has the property of pulling all the objects towards itself. Because of that we are able to stand on the ground on the earth. Yes, so the force which acts on every body, because of that the body is stable on earth, that is nothing but weight. So mass is the matter in a body, while weight is the force of gravity that acts on the body. Let us see the actual difference between mass and weight in terms of physics. Mass is the measure of atoms or the amount of matter in an object, while weight is the force of gravity exerted by an object of fixed mass due to gravity. So this we saw. Let us see the second point here now. Mass is constant for a body. It does not change with a place. So the matter which is needed, let's take an example of a pencil. A pencil is made up of small particles. Yes, pencil is made up of wood. Okay, it is made up of matter. So this pencil, you take it anywhere, you 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 change your city or you change your location, your place, the amount of matter which is present in the pencil, that will never change. Okay, so that is that the mass of a body, mass is constant. It does not change with the place. But if you talk about weight, weight is not constant for a body. It changes from place to place. Now, especially this change is when planets are changing. Okay, we'll see how the gravity changes in my further slides. I'll show you how the gravity changes on the moon, how the weight changes of an object on the moon or on the earth. So weight might change from place to place, but mass does not change. Now, when we want to measure mass of an object, we usually use a bean balance or a weighing machine or weighing scale. So a bean balance is used to measure the mass. Okay, but when you want to take the weight of an object, you can't keep that object still on any balance, okay, on any weighing scale. For that, you need to hang that weight. Okay, you need to, the force of gravity should act on that body, and that is very much possible, that is very uh, visible when a spring balanced is used. So whenever a weight is taken, usually a spring balance is used. Okay, if we talk about the SI units of mass and weight, what is SI? SI is International System of Units. Okay, so usually mass is considered, is taken up in kgs. That means if we are taking, let's say, sugar. Okay, so we take it, we say that we want 5 kg sugar. Means what is sugar? Sugar is nothing but matter. They are particles. Yes. So what is the mass of any object which we take it by a measuring scale or a bean balance? It's taken in kilograms. Okay, because it's just the number of atoms or the matter present in that object. But if you talk about the units of weight is newtons. It is given by capital N. And it's given there where 1 kg, the value of conversion of kg to Newton is 9.8. This I'll elaborate more in my further slides. So the actual difference between mass and weight is that mass is nothing but matter in an object, while weight is the force exerted by an object, okay, due to gravity. Okay, mass of a body does not change from place to place, while weight of an object changes from place to place. Usually a beam balance or a measuring scale, weighing scale, is used to measure mass, and to measure weight a spring balance is used. And the units of mass is kg, while units of weight is Newton. So this was the actual difference between mass and weight. Now let us move on to the formula for calculating weight of an object. Okay, so if you want to calculate the weight of an object, you need to use the formula W, that is weight is equals to m multiplied by g. mg means the sign between them is multiply. They are two different variables, m and g. So now m stands for the mass of an object, while g stands for gravitational field strength or acceleration. Usually we call it as acceleration due to gravity. So if you want to convert mass to weight, you need to multiply the mass with this value g, small g. Okay, so we can convert mass to weight using this formula. Now what is this? What is the value of this g? What is g? Now whenever a free falling object, okay, whenever you allow an object to fall, okay, anywhere from a height, okay, what will happen is it will fall on the earth. Ultimately it will fall on the earth. From wherever you are standing on a high hill, you are standing up on a table or on a chair, but when you drop it, it ultimately reaches the ground, okay, or earth. Now why does this happen? This happens because gravity acts downwards towards the center of the earth. That gravity, the earth is having that force which is called as gravitational force, and it has that ability to pull everything towards itself, and that is also called as acceleration due to gravity. And the value of that is 9.8 meter per second square. So gravity, value of acceleration due to gravity, or the value of that small g on earth, okay, only on earth, is 9.8 meter per second square. So this value we need to use. So whenever we want to convert any mass into weight, you need to multiply by the term g, that is 9.8. So 9.8 is the value of gravitational field strength acting on the earth. We will also see what is the value of this g on moon. As you know, moon, on the surface of moon, there is no gravity. Means a person cannot stand still on a surface of the moon. He cannot walk. The astronauts, they cannot walk freely on the surface of the moon as they can on the surface of the earth. Now why does this happen? This happens because the gravity, moon, on the surface of the moon, we don't have the the acceleration due to gravity which is there on earth, that is 9.8. It is very, very less. If we compare, of course there is gravity on moon also, but that is very less. And how much that is? It is 1.62 meter per second square. So it is approximately 1/6 of that of the earth. Okay, that means if a person is weighing 60 kg on the earth, okay, if a person's weight is 60 kg on earth, when he goes on the moon, it becomes 1/6 1/6 means divide by 6. So 60 divided by 6 will be 10. So that person will weigh 10 newtons on the moon. So this is nothing but because the gravity changes. Okay. Of course, the person isn't changing the matter. The person is made up of bones and muscles and skin. That is not changing. The mass doesn't change. Yes, but the weight changes. Yes, because the force of gravity on the earth is different of that on moon. So it's on earth it is 9.81 meter per second square, while on moon it is 1.62 meter per second square. Let's take an example. Mr. O has a weight of 88.64 kg. Okay. So the mass of Mr. O, okay, mass of Mr. O is 88.64 kg. So what is mass? Mass is matter, means the bones, the skin, the flesh, muscles, organs, everything, the mass, the matter that is made up of, that is 88.64 kg. So if you want to find Mr. O's weight, what you need to do, you need to use the formula W is equals to mg, that is weight is equals to mass into acceleration due to gravity, or gravity, small g. So you need to take the mass of Mr. O, that is 88.64, and you need to multiply that with the value of g, that is 9.8. So you can calculate it with the calculator. 88.64 into 9.8, it will give you 868.7 newtons. So that will be the weight of Mr. O. And if you notice, the units of weight is newtons, that is given by capital N. So we can convert mass into weight by using the value of g. Okay, so you need to remember this value of g by heart. It is 9.8 meter per second square. Let us now see another example now. Okay, in the first image you can see there's a man and he's pulling a mass of 50 kg. While in the second one, in the second image on the top, it's an astronaut who is pulling the same 50 kg weight, but he's on moon. Okay, so let's calculate. So 50 kg mass is not changing, same mass is there on the earth also, on the moon also, that is 50 kg mass. Now let's calculate the weight of this 50 kg on earth, and then let's see the weight of same 50 kg on the moon. So let's see the third image now. Okay, so now 50 kg. Now usually when you go in higher grades, usually what's the value of g? How to convert mass to weight? To convert mass to weight, we multiply it with the value of g, that is 9.81. Now but if you round off 9.81, so if you round this decimal number to a whole number, 9.8, it lies between 9 and 10, so it's closer to 10, or 0.8. 8 is greater than 5, so we add 1 to the previous number according to the rules which are taught to you in math. So it will 9.8 will round off to 10, it's closer to 10. So ideally you can also do, when you want to convert mass to weight, you can multiply it with 10. So in the third image, if you see 5 kg is weight. Okay, mass, you have to convert it to weight, so you need to multiply by 10. Okay, so 50 into 10 will give you 500 newtons. So the same mass, okay, of 50 kg, when weight of it is taken on earth, it will give you 500 newtons. Let's see the last image now. Okay, last image is of the same mass, that is 50 kg, but then how much will be the weight of that same mass on the moon? For this you need to multiply 50 by the value 1.62. Okay, so 50 into 1.62 will give you 18 newtons. So see, mass can remain same. Mass does not change from place to place, but yes, the weight changes. Yes, the weight changes, and you should know that the Gravity on the moon is 1/6 of that on the earth. Okay, so this is the difference, where you can see that how mass does not change from place to place, but weight changes. Okay, let's take one more example now. Now, usually, if it is not given that this mass is on the earth or this mass is on the surface of a moon, usually in the numericals, the value of g is given to you. Okay, so now in this example, there's an object with mass 40 kg, and the value of g is also given, that is 1.6 meter per second square. So if you want to calculate the weight of the object, okay, so now weight here, it is given by F. Okay, what is weight? What's the definition of weight which we saw? Weight is nothing but the force of gravity acting on an object. Okay, so we can say that weight W is nothing but force. That is why in this image it is given here force, that is F. So when you will, in your higher grades later on, when you learn Newton's laws, you will come to know about this equation, F is equals to mg. Okay, now as for now, you can just correlate it with W is equals to mg. So you need to take the mass, that is 40 kg, and you have to multiply with the given value of g, that is 1.6. So 40 into 1.6 will give you 64. And then the units of force is the same as units of weight, and that is newtons, which is given by capital N. So here again, mass is converted to weight by multiplying with value of g. Let's take one more example now. The gravitational field strength on the earth, that means the acceleration due to gravity, that means that small g value, is given 10 Newton per kg. Now see, here the value is given as 10 Newton per kg. Okay, so 9.8 is rounded off to 10. So whatever value of g is given, that we will just multiply with the mass. What is the weight of your mass? That means if your mass is 45 kg, what will be your weight? Okay, so you can also do it for your weight. If your weight is 45, how you will, if your mass is 45, how will you calculate your weight? So you have to take your mass and multiply you need to use the same formula. Weight in newtons is equals to mass into mass in kgs into gravitational field strength, that is Newton per kg. So 45 into 10 will give you 450. Okay, so 450 newtons will be your weight. So this was the major difference between mass and weight. Okay, I was talking about the units of mass. Mass is calculated in kgs, while weight is calculated in newtons. So newtons with this name, do you know the fact? Do you know that from where this unit newtons has come? So you know the scientist, the famous, very famous scientist Isaac Newton. Yes, so the weight has got its unit newtons, that is capital N, from the scientist Isaac Newton. And I hope you know this situation. Okay, one day when Isaac Newton was just sitting under an apple tree, what happened is he saw an apple falling down and ultimately reaching on the ground. Okay, that made him think that why this apple reached the ground. Why is it not hanging in between anywhere? Or why is it not moving in the air? Why is it reaching on the ground only? So that made him discover the force that the earth is having, that is nothing but the force of gravity, that is acceleration due to gravity. And this was how the acceleration of gravity or gravitational force was invented by him. So with his name, and this force of gravity is acting on any object is nothing but weight of an object. That is why the units of weight is given in his name. Okay, that is Newton's, capital N. Thank you, students. This was about the whole session. I hope you liked it.